very excited that we're partnering today with MCP Connect. We're been always supporting the tech landscape and tech events, and we're super excited to run this very first event in Berlin with you guys. So please, a round of applause to you guys for actually organizing this. It's super good stuff. Yeah, so as I mentioned, we at Superhuman have been running these events here in Berlin, or different kinds of events here in Berlin, not this kind of, this is unique. It's a really unique one. For quite some years, over 3 years, and previously we've been known under the name Grammarly. Hopefully some of you, or many of you, know and use that product. I hope so. So yeah, what's the deal? What was the new name? So as a company, we started about 2009 as the Grammarly AI writing assistant, and there's over 40 million users that are using our product daily, which is very, very nice, and we love it. And last year we acquired a couple of companies, one called Coda.io, another one was Superhuman Mail, and then just recently Rose. Rose is like rows in a spreadsheet, because that's what they're doing. And this kind of expanded our mission and vision of the company much broader, and we decided to rebrand to Superhuman and kind of describe much broader landscape of what we're doing. So we moved from just being a writing assistant to a much bigger thing. So what that bigger thing is. So really we became like this suite of productivity apps and agents, of course, these days, agents, other things, like why not? That really help you getting things done. So it's not just writing stuff, it's much more than that. But what that means in practice, like in US is Grammarly, and Grammarly is an app still there. You can still continue using it if you love and use it. It's there. There's also Coda, which is a document collaboration platform. So many of you might know the Notion, which is a competitor. This is a very similar tool, but more powerful in many different ways. Encourage you to try. We also have the Superhuman Mail. That's the modern email client for the age of AI. And we, not so recently, but not so long ago, announced another product, which is called the Superhuman Go, which is a proactive AI assistant that helps you getting things done. So it's not just writing, it helps it understand the context in which you work, and brings the knowledge to the place where you are. So you don't need to copy paste to different AIs all over there. It's in a place where you work. So that's a few words about the company itself. And we are based here in Berlin. We have a couple offices in Europe and all over the globe. Here we're this building. Soon, hopefully, we'll be moving into a bigger space. So if you're interested, of course, in any positions, we have quite some few. So, and there are colleagues around the room that can help you. Oh, yeah, that's the one. I skipped the previous one with all the nice titles. But yeah, to wrap the things up, so if you're interested in any positions that we have, of course, talk to us, to my colleagues or me, happy to talk about all the position stuff. And now moving to the most interesting thing, so I'm not talking too long, I'd like to pass the word to my colleague Viktor, who's going to be talking about the AI at Superhuman, and he's actually an expert in all things AI. He's been doing machine learning and stuff way before LLMs became cool, so he knows a shitload of things.
Thank you. So I've been to AI hackathon in Hamburg 3 weeks ago, and my most frequent conversation was, where are you from? I'm from Superhuman. What is Superhuman? Do you know Grammarly? Grammarly, yeah, we know it. And then, what is Coda? Do you know Notion? Notion, we know it. So definitely there is a lot of challenge in the way how brands works. Okay, so where is my slide? So I'm Viktor, I'm Director of Engineering here at Superhuman. I've been doing ML for quite some time. Probably now we have LLM, so everyone can do ML as well. Just start your Claude code and you're an ML engineer, nothing else, nothing more. But at Superhuman, as I mentioned, Superhuman is a brand for a company, but also it's a product. It's a product which is called Superhuman Go, which is a system. And there is a lot of things that this product brings to where you write. So instead of copy-pasting your text, for example, from your text surface to ChatGPT 10 times a day, you could actually bring ChatGPT to your surface. And it's just a connector on Superhuman Go platform. It also connects all the sources that you have as a private person or as a company all together and brings it to the LLMs. Like to give it a perspective, my most favorite feature, which currently in alpha, is our people card. So whenever you see a person name, whether it's Slack, Gmail, any other service, you can just hover it and see what is your next one-on-one with this person. What was your last Slack conversation? What was your latest email thread? Or if you're in sales, it's like, what's the Salesforce account? What's the LinkedIn profile? And so on and so forth. So you can imagine that all these connectors do matter to all the features. And the way how they connected, obviously it's MCP. Well, we do use a lot of APIs, but our users do use a lot of free-form asks to those connectors. My most probably favorite thing, we had a user who was a beta user for Superhuman Go. They connected everything, like all the possible connectors to Superhuman Go, and they asked one very existential question: what should I do next? How do I know, man? Like you probably need to ask your therapist. We tried to assist, but we definitely failed. Okay, but MCP is actually started just recently, right? So, well, it's almost a year and a half right now. And there is a number of articles, blog posts, you probably read all of them. So how MCPs are different from APIs, is it the same thing, are they different, and so on. We're learning along the way as you all, and probably there is a bunch of things which are now controversial for us. So we definitely do know that MCPs are kind of not the same thing as APIs. But on the other hand, we know that LLMs are now crazy good at writing code. Probably all your non-engineering counterparts already said to you that we don't need engineers. LLMs could do everything for us. I bet any one of you heard this at least once in your career over last month. And if models are good for writing code for APIs, do we actually need MCPs? So how do we evolve there? And that's what we're trying to learn from this talk. But in order to understand how to get there, probably the most important thing is actually being able to evaluate things. Because if we can't measure something, we can't really improve it. And there is a list of test cases that I'm going to use over the sandbox environment. So all of these are real use cases and real questions from our beta users. And they ask a lot of things about their calendar and scheduling, starting from, what are my meetings for today, all the way to, how do I find all my recurring one-on-ones and just color them in a green color? Because I was testing these use cases on my real calendar. Now my real calendar, a little bit of rainbow, starting from green to red and orange. So if you're not using color coding in your calendars, could recommend. It's pretty fun. It also could help you to understand where your time going in. So all these use cases are taken from real product against a real calendar, and let's see how actually it works. But before we go too deep into details, this is my architecture for Sandbox, sponsored by Claude. Thank you, Claude. Doing great. I have a layer of API integrations, which is just a pure Google Calendar official Python API. I have two MCPs. One is a fast MCP, which is, if you don't know where to start with fast MCP. It's amazing. You could actually wrap your API in fast MCP in probably 5 minutes, and it will work pretty good. There is another Google Calendar MCP, which is a little bit disappointing to me, to be honest. It's most popular MCP server for Google Calendar on GitHub. It has 1K stars. However, it has exactly the same problems as fast MCP. So generally, for me, no benefits between two of those. Variety of models from Nano all the way to Pro, which is not listed here, but actually I tested for different models, and a holistic evaluation. So again, I want to highlight evaluation here is probably one of the most important parts. If we can't measure something, we can't improve it. It contains, because it's all was run against my real calendar, so I know what kind of meetings I want to find. I manually created the golden set and set up, again, one of the anthropic models as LM as a judge. If you're interested into this thing, just catch me up in the break. I'm happy to talk about evaluations probably for hours, which will take you away from pizza and beer after the meetup. Okay, so here we go. Our fast MCP evaluation looks as following. Simple cases from U1 and U2, just like list my meetings today, find my next meeting with a person, actually pretty good. Not surprising that Pro model actually went pretty high. However, I'm surprised that it actually didn't score perfectly on all the examples. Not a surprise that Nano model is the smallest model. It actually has the lowest success rate. It's actually hallucinated a lot. Mini and just regular POP 5.2 kind of in the same place. I want to mention here that I don't know if you worked with 5.2 model, a regular model. It has different configurations. One of the configurations would be what is the reason and effort you want to have, and in this example it was automated, so like it's set to default, which means that it could be somewhere between Mini and Pro based on what God of OpenAI decide to how many tokens they actually ready to spend with me. There is a lot of on this graph. We will be focusing particularly on test case number 3 till the rest of the presentation. So if I zoom into test case number 3, again to remind, this case sounds like find all the meetings for me for this week, all the upcoming meetings, so it's important. We don't want to look at the past, that I don't have a room for. I don't know like how many of you are in the situation when you have a meeting, but then you don't have a room for the meeting. It's quite often for me, and I often sit somewhere in wardrobe between all the jackets. What's interesting here is that actually you can see the error bars and confidence intervals pretty wide and pretty crazy for smaller models. And even for Pro model, it actually didn't get perfect score all the time, and it missed a few events in a couple of runs. And it's pretty frustrating, to be honest. So I don't know like how how you think about it. Maybe I must admit one thing. So when I was preparing this talk, is Anya here? So Anya told me, Anya on the backend, so I need to have either a joke or a question for the audience to get better engagement. I prepared a joke, but then comms team banned my MCP meme right after that. So they said, no way you can actually show this to the audience, to the community. It's not gonna work. So sorry, I'll leave you with a question. Just bear with me. How many of you actually like was frustrated when your second LLM run or call was different from the first LLM call, and it was actually probabilistic? I'm happy that like for me this happens all the time, and it's a disaster. So like that's why we see such much variation in the stability. So question for today: can we get everything to 100% or not? And if you want to get to 100%, what do we need to do on both sides, on the model side and on MCP side? But before we can actually get to the 100%, we need to understand what's happening behind the scenes. So what is the reason for failures? Again, if we can't measure something or we can't understand, can't debug, there is very little things that we can do to improve. There is 4 things which are the most frequent failure factors in my scenario. Hallucinations. Nano model here is actually on the top. It made up my calendar, my schedule completely. I have such interesting meetings that actually I never had in my life with Nano model, thanks to Nano model for that. Filtering, filtering is actually an interesting example. So there is 2 ways how we can filter, on a backend or on a model side. And we could just dump all the events from backend to model and ask model, filter it for me, so find like an event. It will try to do bad, but it's actually not their strength. So they, behind the scenes, they try to build like a filtering pipeline, do all the reasoning and so on and so forth. And the longer context, so the longer they try, the more they hallucinate and the more they fail. So a lot of things work failing on the filtering stage. And if you want to have good filtering, we actually need to move it to backend as much as possible. Time zone chaos, not specific for test case when you need to find upcoming events, but calendar API, very interesting the way how it starts. Time zones, and the models are pretty bad in converting time zones. They have no clue about, well, they do have, but they don't apply it constantly. Summer time, winter time, when is it changing? So it's actually very interesting how they think about it. And finally, last but not least, I believe this is one of the important things to develop good MCPs, is the context size. So we can actually fit a lot of things into model, but at some point of time, model say, nope, I'm fed up, I'm done with that, and we'll just silently drop everything that you don't know or you're not aware about. So the more things we feed into model, the higher our probability that it will stop at some point of time, and will just silently, that's the worst case, so silently drop everything else from the context. Okay, so a little bit of sneak peek, I'll talk about this in details, but I took fast MCP, which is V1 on this chart, and tried a little improvement. So my goal was, is there any small things that I can tweak in the MCP implementation to get it from 25 all the way to the 100? Answer is probably yes for Pro model and no for Mini and a regular model. So what is the difference between all these versions? Between V1 and V2, difference is very, very simple. So instead of returning in the calendar event list of attendees all the time, the only thing that I changed, I added two parameters on my MCP implementation, which say include attendees and include rooms in the response. And they both false by default. So what it changed? Now, when model calls my MCP server, it gets a way smaller response without all the attendees by default. And if it wants, it would actually also include a room in the response. Surprisingly, all the models were pretty good in identifying that, hey, it's like there's something in the prompt about the room, so I probably need to include room, and they all included actually this flag include rooms in the response. And you can see that it's actually boosted quite a lot. So now Pro model was 100% stable. All other models get quite a lot boost. So one very simple fix actually did a lot. Second fix between V2 and V3 actually added another thing. So it added pre-calculated flags in the global response. So now it also has, so to be specific, there was a flag which said in every response, has room in one of our major locations. So has room in New York, has room in SF, or has room in Berlin. Everything else was merged together as has room in other. I'll show you where it actually played the trick in a second, but that's all. So just two simple tricks between one and second. One, have a filter on backend what to include. This reduced context drastically. So reducing context drastically actually help a model to reason better. Second, has some pre-calculated fields. Again, not cheating, but a little bit of aggregation on backend. To see in real numbers, all of this was run with 10 different runs behind the scenes. So we repeated exactly the same test case with the model 10 times, and average a score, calculated confidence intervals. You can see that Pro works pretty well, Mini is a second place, and followed by regular model. However, still the problem, we can get to 100% with smaller models. Nano hallucinated all the way up to V2. I decided not to actually murder it going into V3. What's the problem? So this is one example from GPT Mini and V3 run. So it has 10 runs, 2 were 100% successful. The rest of 8 runs shown here. And the problem is that we don't actually see a pattern. So, well, meeting A is obviously a repeatable one, it's always missed, but all other meetings kind of random. And it's probably 20% of overall meetings in the test set. So overall test set was 20 meetings, something like that. But there is no pattern, unfortunately, which means that model actually hallucinates still a lot and tries to solve problem which is not solvable by model per se. And at least like at this level of model. So just a few things that I want to take away from this research before I move to the next slide, where I'll leave you with a cliffhanger a little bit. MCP is probably first one. If you're building an MCP, just don't overthink it right away. Start with a simple API wrapper and try to use the biggest, largest possible, the most comprehensive models that you can actually have. The tweak here, or the trick here, you won't be able to get to good results if you don't control both ends. So if you control only MCP, you have no actually availability or no way to control the caller model. You have no idea what the model is, and you can't guarantee the quality. Someone might actually call your absolutely perfect MCP with another model and say, then post on LinkedIn that, you know, this MCP is pretty bad because it returns something pretty wrong to my model. But the problem is model, not MCP. Less is more. So context windows are finite, and we need to do whenever we can to actually reduce the size of context window. All the LLM providers will definitely tell, oh, we have now 1 million context window, we have 100 million context window. Unfortunately, it's a lie at the moment, and actually, computation token budgets are very, very real on all levels, from the very small to larger models. It will perform better if we feed less data to the model. And MCPs is actually a great place for business logic. When I started experimenting with this two example, I need to make quite a few business decisions. Do I want to include only accepted or all events? If I want to, do I want to include, for example, halts? Do I want to include out of the office events in the return list? For the sake of fair comparison, I moved all this business logic to the prompt. However, MCP is a way better place to have it if you know that it could be stable, and just add a flag to your function or request that it could be filtered or configured in a particular way. It would work probably thousands times better because it would be a deterministic thing. And all of this actually leads me to the question is, are we optimizing for the right thing? I know that's an MCP meetup, so I'm going to do a little push out of the MCP. So that's a protocol that emerged a year and a half, and it did a long way and did a great job. But now we're seeing that actually a lot of implementations and a lot of things they're switching gears from, oh, I do need actually just a prompt or instruction to get things done, to the way it's faster for LLM to write a code to do something. So maybe dynamic code generation could be a next answer or next big thing in this game. So now models are really good. I hope everyone actually uses some kind of AI-assisted code generation at the moment. If you don't, just give it a try. So models are good enough to write correct API calls, and APIs were developed for developers, for engineers, so models do know how to call them correctly. And maybe at the very first time when the model experiences or faces a new request, it could dynamically generate code behind the scene. We can use the largest possible model in the world to do this because we're doing this only once. And then we convert it into reusable artifacts that we execute in a secure sandbox. But at this point of time, it already runs deterministically. Every single time you execute the same code, you're getting the same response. It's important. And we involve a new model, or new model call only when there is no matching tool exists. It's a new tool. We create a new one, we generated a new one, we put it into our tool artifactory, we set a timeline for it, we cached it for, I don't know, for a week, for 2 weeks. If there are no additional usage within 2 weeks, we just drop it silently. But if we're able to generate a code, have an artifactory list, store all the tools, and have a good retrieval layer which says us which tool would be helpful in this situation, we actually solve all these problems. So we have a deterministic way, we optimize for latency and cost because even small model actually able to use tools. We don't need to be pro-level smart. We have pretty good cost economic, and we're also using the power of the frontier models at the end because the frontier model generates this code. So I don't know like that this thing is currently in production, but definitely I do see a lot of movement in this direction. Thank you everyone, and ready for questions.